Good morning, children. We are continuing with complex numbers, exercise 2.2. Here we are learning the basic operations on complex numbers: addition, subtraction, expansion, in that way. Given two numbers, we are going to find out what is z plus w. Now remember, z is 5 minus 2i and w is minus 1 plus 3i. Addition implies real and real. 5 minus 1, 4. Imaginary and imaginary. 3i minus 2i is plus i. So the answer z plus w equals 4 plus i. You can also write side by side and do it, or you can write one below the other. Now we want to find out z minus iw. Second question. Let us write down what is iw first of all. What is iw? I multiply with minus 1 plus 3i. My answer will be minus i. 3i into I will be I into minus 1 minus I. I into 3I will be 3I square. And what is I square value? Minus 1. So minus 1 into 3 minus 3, and here there is minus I. Now my question is z is nothing but 5 minus 2I and minus iw. We had already got what is iw. Minus iw means change the symbol. So this will become 3 plus I. Find the answer. This is z minus iw. 5 plus 3, 8. Minus 2i plus I is minus I. So z minus iw is nothing but 8 minus I. 2z plus 3w. This is equal to what? Find out 2z. That means the z multiply by 2. 5 2s are 10 minus 2i into 2, 4i. Then I want 3w. W multiply by 3. Minus 1 into 3 minus 3. 3i into 3 plus 9i. So my answer will be 7 plus 5i. So in these problems, we are learning addition, multiplication with the I, 2z plus 3w, scalar multiplication. Z we multiply by 2, scalar multiplication. W we multiply by 3, that is also a scalar multiplication. And then we add. So general result to remember, addition means real and real we have to add. Imaginary and imaginary we have to add. Another subsection, find z plus w the whole square. We already found out z plus w. The answer was 4 plus I. And I want the square. So our usual expansion, this is a plus b the whole square. A square plus 2ab plus I square. 16, 2 4s are 8i. I square value minus 1. 16 minus 1, 15 plus 8i. Now there is one more question of this pattern. Z square plus 2zw plus w square. You can find out what is z square. 2 into z into w square, add it. Or else this is nothing but a square plus 2ab plus b square. So I can also write this is z plus w the whole square. And z plus w the whole square, a little earlier we have found out. So what is the answer? 15 plus 8i. Question number 3. We are given two complex numbers which are equal. Find x and y. First, let us simplify this answer. That is, all that is with I, all that is without I. Because we want to write a plus ib form. So, take this one. 3 minus I into x minus 2 minus I into y plus 2I plus 5. Simplifying this, let us first multiply. 3 into x minus I into x minus 2 into y. Minus into minus plus iy plus 2I plus 5. Collect all that is without I. So that is real part. 3x is there, minus 2y is there, plus 5. So all these terms are without I. Then I into all that is with I, minus x plus y plus 2. So this is the answer for the first complex number. Same pattern. Let me simplify this answer. 2x plus minus 1 plus 2I into y plus 3 plus 2I. Simplifying this, 2x minus 1 into y minus y plus 2I into y plus 3 plus 2I. Collecting all that is without I. 2x minus y plus 3 plus all that is with I. 2iy. I have taken I out. So this is 2y plus 2. The question says these two numbers are equal. Equal means compare real and imaginary. So whenever I say two numbers are equal, we will say the real and real must be equal. The real part 3x minus 2y plus 5 equals to the real part 2x minus y plus 3. And imaginary and imaginary are equal. The imaginary minus x plus y plus 2 equals 2y plus 2. This implies 3x minus 2y plus 5. Bring all this to the left side. Minus 2x plus y, or even I can bring 5 to the other side. So I can say 3x minus 2y minus 2x plus y equals 3 minus 5. 3x minus 2x is x. Minus 2y plus y is minus y. 3 minus 5 is minus 2. So this is termed as equation number 1. Simplifying this. Minus x plus y, bring 2y this side. Minus 2y equals to 2 minus 2. Or I will simplify. It is minus x minus y equal to 0. So this is, I can change the symbol, x plus y equals 0. Call this as equation number 2. Now let us solve 1 and 2. First equation is x minus y equals minus 2. Second equation is x plus y equals 0. Just ordinary addition. Plus y minus y cancels. 2x equals minus 2 means x is equal to minus 1. Put x is equal to minus 1 here. Minus 1 plus y 0 means y equals 1. So my answer, x is equal to minus 1 and y is equal to 1. The given question says two complex numbers are equal. So we try to check. Two complex numbers are equal means compare real and real, imaginary and imaginary. From which I get two equations. Solve the two equations Take and write the answer. X is equal to -1, Y is equal to 1. Question number 2. Z equals 2 plus 3i. We need to represent Z, I into Z, Z plus IZ in Argand diagram. Let us find out what is IZ. I into Z value. I into 2, 2i. I into 3i, 3i square. What is I square? -1. So minus 1 into 3 is minus 3 plus 2i. So this we call IZ. I also need Z plus IZ. Z value 2, IZ value -3. 2 minus 3 is -1. 3i plus 2i, I will say 5i. Let us see all this in the diagram. Real axis we have taken, imaginary axis. We can have some more numbers here to mark all this. Z 2 plus 3i means 2 in real axis, 3 in imaginary axis. So this is the point. 2 in real, 3 in imaginary. So this is Z. It is 2, 3. And I want IZ. What is IZ? -3 plus 2i. So mark some more values. -1, -2, -3. So my answer is -3 plus 2. So this is the number. So I have -3 plus 2. This is I into Z. The next I want is Z plus IZ. The value is -1, 5. So it is somewhat here. So this is Z plus IZ. Now you can see if I join it with a scale, you can see it becomes a right angle triangle. You can very well check using Pythagoras theorem. So in all the problems, Z, IZ and Z plus IZ will definitely form a right angle triangle. We also need to find Z minus IZ, Z minus IZ in the Argand diagram. Z already we know it is 2 plus 3i. Now I want minus IZ. Minus I into 2 plus 3i. Minus I into 2 minus 2i. Minus into plus minus 3i square. I square minus 1. So minus 1 into minus 3 is 3 minus 2i. Let us remember, in all the problems, first we will write real part without I. Then only I will write with I, imaginary part. Now what is Z minus IZ? 2 plus 3, 5. 3i minus 2i is plus I. We'll mark all this in the diagram. 2, 3. So this will be Z, which is 2, 3. Minus IZ is 3 minus 2. So this is the point. Minus IZ. 3 minus 2. And now I want 5 plus I. 5 will be somewhere here. I will be here. That is 1. 5, 1. So this is Z minus IZ. You can join with a scale and check. This is also a right angle triangle. So we conclude Z plus IZ, Z plus IZ is also a right angle triangle. Z minus IZ, Z minus IZ also form a right angle triangle.